During the previous lecture, we discussed the overall process of data mining. And one of the key steps in the process of data mining is data wrangling. So today, we are going to focus on this important topic of data wrangling. It is one of the key steps in data mining, but often overlooked in many business analytics courses or books. So in today's lecture, we are going to put a special emphasis on the topic of data wrangling, because without an understanding of data wrangling, analytics would not be possible, or at least not going to be very fruitful. In this lecture, we are going to discuss some of the key and common data wrangling activities, including inspecting and exploring data, how to handle missing values, subsetting data into different data sets, and how to perform various data transformation. At the end of this lecture, you should be able to understand the key data wrangling steps that are required to support subsequent analysis and perform these steps in both Analytics Solver and R. Data wrangling is the process of retrieving, cleansing, integrating, transforming, and enriching data to support analytics. It serves many purposes, often more than what people think. It is often the bottleneck of many business analytics projects. You, as an analyst, cannot move on to the next step if you don't have the skills to wrangle the data effectively. In this lecture, we are going to focus on three key phases of data wrangling: data inspection, data preparation, and data transformation. During the data inspection phase, you review and explore the data set to assess data quality and the relevant information for subsequent analysis. So this phase provides you with a good understanding of the data you are dealing with and their data quality issues. And this steps also helps to formulate a plan for preparation and transformation steps in the future. The data preparation phase involves handling missing values and subsetting data. This phase helps prepare the data so that they are usable and serve the purpose of your analysis. And data transformation involves converting data from one format or structure to another to meet the requirements of the analytics techniques and enrich the data at the same time. So this phase makes your data readily usable to the data mining techniques you are going to use. It also helps bring information out of the data. Data transformation steps usually include transforming numeric, categorical, and the date and the time data types. More complex data preparation and transformation are required for unstructured data, such as text, audio, and video. However, that topic is beyond the scope of this lecture. We may discuss these topics in the text mining lecture in the future. So let's talk about data inspection first. When the analyst receives a set of data, the first thing he or she should do is to inspect the data, maybe even using the visualization techniques to view the data. But visualization is a separate topic for a different lecture. So two other common tasks that are often performed during the data inspection phase are counting and sorting. Counting and sorting would allow us to gain some insights about the data that we are dealing with, and also allow us to find out whether any important values are missing, okay, and what are the ranges of the values of each variables. So let's look at an example here. So we have a data set here from a company called Balance Gig. Balance Gig is a company that matches independent workers for short-term engagements with businesses in the construction, automotive, and high-tech industries. So a manager at Balance Gig created this worksheet from their employees' most recent work engagement, including the hourly wage of the employee, the client's industry, and the employee's job classification. Okay, so a portion of the data is shown on this slide. As you can see, there are 4 columns in the data set: employee ID, hourly wage, industry, and the job. The manager suspects that some data may be missing in this data set. So she is trying to find out the number of missing observations for the hourly wage, industry, and the job variables. Right. So as you can see, this would involve some counting. She would also like to find out the number of employees who worked in the automotive industry, and also the number of employees who earn more than $30 per hour, and also the number of employees who meet both criteria. So as you can see, again, this would involve some counting. Finally, she would like to find the lowest and highest paid employees at the company and in the automotive and the tech industries. So that would require some sorting to find that information. So now let's look at how we can do this in Excel and R. Okay, let's look at how we can do the counting in Excel. So first, I have opened the file, the gig data file in Excel. And as you can see, there are 4 variables in the data set: employee ID, hourly wage, industry, and the job. If you scroll down to the end of the file, you will see that the last row is row number 605, because the first row contains the variable headings. That means there are a total of 604 records in this data set. In order to count the number of missing values in the data set, we can use 2 functions. One is the regular count function, and the other is the count A function. So what's the difference between these 2 functions? The count function will count the number of cells that contain numeric values. So it will only apply to 2 of the variables in our data set, which are employee ID and hourly wage. If you try to use the count function on industry and the job, you are not going to get the correct result. However, count A function would count the number of cells that are not empty and is applicable to all 4 variables in our data set. Alright, so in order to find out if we have any missing values for hourly wage, what we can do is we can either use the count function or the count A function to achieve that. So for example, let's find an empty cell and enter the function equal count, and then in the parentheses we are going to enter the range of cells that contain the values for hourly wage. And what I can do is I can highlight these cells and press enter. As you can see, we'll receive the answer 604. So since we have 604 records in our data set, and we have 604 values in this particular field, that means there is no missing value for the hourly wage field. You can also do this using the count A function if you want. If you type in equal to count A and then enter the same range of cells for the values for hourly wage and press enter. As you can see, you get exactly the same answer. For industry and the job, we need to use the count A function. So for example, if we want to find out the missing values in industry field, we need to use the function equal to count A, and then enter the range of the cells that contain the values for industry. As you can see, we get the result 594. Since we have a total of 604 records, that means 10 values are missing for the industry field. What about the job field? Well, let's find out. We can type in equal count A and then enter the range of cells that contain the values for the job variable. And as you can see, we got the result 588. Since we have a total of 604 records, that means there are 16 missing values for the job variable. So as you can see, by using the count or count A functions, we're able to find out that there is no missing value for hourly wage, and 10 missing values for industry, and 16 missing values for job. Now let's look at how we can count the number of employees in each industry. In order to do that, we need to use the COUNTIF function because we are introducing a criterion to the count function. So if we want to find out how many employees worked in the automotive industry, what we can do is find the empty cell, enter the function equal to count if open parenthesis, enter the range of cells with the value for the industry, which is C2 to C605, comma, and then you enter the criterion within double quotes, double quote equal to automotive, double quote, close parenthesis, and press enter. This gives you the answer 190. So this shows that out of the 604 employees, 190 of them worked in the automotive industry. Similarly, if we want to find out how many employees make more than $30 per hour, we can use the COUNTIF function to find another empty cell. We're going to enter the function equal to COUNTIF open parentheses, and this time we're going to highlight the cells where you can find the values for the hourly wage, which is B2 to B605, comma, and then enter the criterion and put them between double quotes, double quote, greater than 30, double quote, close parenthesis, press enter. And you get the result 536. That shows out of the 604 employees, 536 employees earned more than $30 per hour. If we want to find out how many employees worked in the automotive industry and earned more than $30 per hour, then we need to use the COUNTIFs function. So this is how this is done. So find an empty cell, we enter the function equal to COUNTIFs open parenthesis, and first we enter the criterion range for the first condition, which is working in the automotive industry. So we select the range C2 to C605, comma, enter the criterion, double quotes, equal to automotive, double quotes, comma, and then enter the range for the second criterion, which is the hourly wage, cells B2 to B605, comma, double quotes, greater than 30, double quote, and then close parenthesis, and press enter. As you can see, we get the result 181. So this shows that out of the 604 employees, 181 employees worked in the automotive industry and earned more than $30 per hour. Now let's look at sorting. To sort all employees by their hourly wage, to find out the highest and the lowest paid employees in the company, what we can do is we can highlight the cells A1 through D605. Okay. And then go to the data menu, go to sort, and here in the sort dialog box, we are going to select sort by hourly wage, sort on values from the smallest to the largest, and click OK. This will sort all the records based on hourly wage values. As you can see at the top of the sorted list, there are 3 employees with the lowest hourly wage of $24.28. And then if you scroll down to the end of the list, you'll find that the highest paid employee is an employee that worked in the construction industry, and it was paid the hourly wage of $51 per hour. If you want to sort the data based on multiple variables, for example, based on their hourly wage as well as the industry, you will do the same by highlighting the cells A1 to D605 and go to data and sort. This time we are going to first sort by the industry. So we will choose the industry and then sort on values from A to Z or in ascending order, and then click on the add level button, right, and then choose hourly wage in the second then by option, and the smallest to the largest, again in ascending order, and click OK. Now in the sorted list, we can see that the lowest paid employee in the automotive industry is a programmer who makes $24.76. And then the highest paid employee in the automotive industry, if you scroll down, would be an engineer who is paid $50 per hour. And then in the tech industry, the lowest paid employee was a sales rep who made $25.17 per hour, and the highest paid employee was an engineer who made $49.55 per hour. Now, to return the data to its original state, all we need to do is highlight the cells A1 to D605 and go to Data, Sort, and sort by. Let's first remove the level, second level, and then change the sort by to employee ID from the smallest to the largest and click OK. And this returns the data to its original state. Now let's see how we can do this in R. In order to use R to do the counting and sorting, I'm going to start RStudio. And this is the interface of RStudio. The first thing I will do is I need to import the data set. So I go to Import Dataset from Excel, and I'm going to find my file that has the data set I need, which is chapter2_data. And then I'm going to select the sheet with the gig dataset. So gig dataset, and I'm going to change the name of this data set, which is called a data frame in R, to my data. Click import. Right. So as you can see, RStudio has imported a data set into R with the 4 variables and 604 records. Okay. So I'll go to File and create a new file, an R script file. So that gives me a space for typing in my R script. A common function that we usually use when we try to inspect the data is the dim function, which stands for dimension. So for example, if I type in dim my data, and if I click on run, the result shows me that I have a data frame that has 604 records and 4 columns. So this shows me the dimension of my data set. If I want to have an idea of some of the values in the data, I can use the head function. Head my data. If I click on run, it will show me by default the first 6 records in the data set. So as you can see here in the result, it shows the first 6 records that are in the data set. And in order to find out the missing values in my data, well, R stores missing values as NA. So there is a function called the is.na function that will allow me to identify the missing values. So if I want to find out if there is any missing values in the industry field, what I can do is I can type in is.na, and within the parentheses I'm going to type in my data, which is the name of the data frame, and then $, followed by the name of the field that I'm interested in. And in this case, I'm interested in any missing values in the industry field. So I select industry, and I'm going to run it. Okay, what you're getting is a bunch of true and false. Okay, what you're seeing here is basically the is.na function will label the observations with missing values as true and observations without missing values as false. So as you can see, some of these, most of these are false, which means they do not have missing values. But if you look at this one, okay, this one is true, which means there is a missing value here, and there is a missing value here as well. Right? If you have a large data set, having to go through all observations would be inconvenient. So alternatively, we can use the which function together with the is.na function to identify which observations actually contain missing values. So what we can do is we can type in which and is.na, okay, and within them parentheses, we are going to type my data $industry. Right. Now if I run this script, as you can see, the result shows these records are the ones with the missing values. Record number 24, record number 139, record number 361, and so on. Those are the ones with missing values. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are 10 records with missing values in the industry field, which is exactly what we got when we counted the number of missing values in Excel. Okay. So just to inspect the first record with the missing value, what we can do is we can type in the script my data, this square bracket, okay, and 24 comma and a space. If I run this script, what it will do is it will show me this particular record. So as you can see from the result, it shows that this is employee ID number 24 with a wage of $42.60, but the industry field is missing. That's why it has the value NA, okay? And the job is sales rep. Okay? So as you probably have noticed, there are two elements in this command, right? The first element, 24, is the row number, and the second element here is supposed to be the column number. Because we left it blank, it displays all the fields for that record here for us. So in order to find out how many records have missing value in the industry field, we can also use a function called the length, which will count the number of records for us. So what we do is we use the length function, okay, and then have the which function within it, and have the is.na function within it, my data $industry. Right, so this is going to tell me how many records I have missing value in the industry field. So if I run this script, I'll get the result 10, which shows me exactly how many missing values I have for the industry field. So you can do exactly the same thing for the job field. So if you type in length, which is.na, my data $job, okay, and if you run this script, you get 16, which is exactly the same number of missing values we found in Excel. Now, to count the number of employees who worked in the automotive industry, or the employees who earned more than $30 per hour, okay, we can use the same strategy. We can use the function length, and then the function which. Okay. And for the which function, we are going to put in my data $industry equal, but this time we are putting a double equal sign, which is also called the equality operator. And this is used to check whether the industry is automotive or not. Okay. So, and the single quote, automotive. Okay. When I run this script, this will show me that 190 employees work in the automotive industry. So if I want to find out how many employees who are paid more than $30 an hour, I can use the same strategy. Length, which my data $, and hourly wage, and in this case I'm using the greater than sign, greater than 30. Okay, and I don't need to use the single quote because the wage is a number field. I only need to use the single quote when I have a text field that I want to compare it to. So if I run this script, I should have the result 536. If I want to find out how many employees worked in the automotive industry and were paid more than $30 per hour, then what I can do is I can combine the two criteria together using the AND operator. Okay, so this is how I want to do it. I'll type in length, which my data $industry double equal sign single quote automotive, okay, and then followed by the AND operator, which is the ampersand, okay, and my data $hourly wage greater than 30. Okay. So now if I run my script, I'll get 181 employees who worked in the automotive industry and earned more than $30 per hour. Now let's look at how we can sort in R. To sort in R, we use the order function. The order function will give you the row number of the records in either ascending or descending order. So for example, if I want to sort all the records by the hourly wage in ascending order, I can use the order function in this way. Order, and within the parentheses, I'm going to put in my data $hourly wage. If I run this script, as you can see, what I get is a list of row numbers. This is sorting the hourly wage in ascending order. As you can see, record number 467 has the lowest hourly wage. That's why it's number 1 in the sorted list. So what I can do is I can create a new data frame that will store the sorted list. Alright, so I'm going to name my new data frame sorted data 1 and use the assignment sign in R and type in my data and the square bracket order my data $, sort everything by hourly wage in ascending order, and comma space. Okay. Now if I run this, you'll see nothing is shown here. The reason is because the sorted list has been stored in a new data frame called sorted data 1. So if I want to see what's in sorted data 1 data frame, what I can do is I can use the view function. One thing to keep in mind is that R is case sensitive. So for the view function, the V needs to be capitalized. Sorted data 1. Right? When I run this script, I'll be presented with a list of records in its sorted order. So as you can see, at the very top of the list, I have 3 employees who earned the least amount in terms of hourly wage, $24.28. And if I scroll down to the bottom of my list, and it shows that the person who earned the most in terms of hourly wage is employee number 110, who earned $51 per hour. So if I want to sort data by multiple variables, what I can do is I just specify the variables in the order function. So for example, if I want to sort the data in terms of the industry and then by hourly wage, what I can do is I can use order my data $ industry first, then comma my data $ hourly wage. So this sorted list will list the records first by industry and then within the industry by hourly wage. So again, I can create a new data frame to store this sorted list. So I'm going to call this new data frame sorted data 2 and use the assignment sign here and my data bracket and use the output of the order function as the row numbers and then comma space and close square bracket. Okay. Now run this script and then to view the new sorted list, you can type in view sorted data 2 and run this script, and there you go. Now we have a new sorted list. So as you can see, the new sorted list will sort all the records by industry first. So as you can see, all the automotive related employees are at the top of the list, and at the bottom of the list we have the records with no industry included. And the very last industry that's included here is the tech industry. And then within the same industry, employees are sorted by their hourly wage in ascending order as well. As you can see, in the automotive industry, the lowest paid employee earned $24.76 per hour. And the highest paid employee in the automotive industry would be employee number 79, who earned $50 per hour. And within the tech industry, the lowest paid employee is a sales rep and also an engineer who made $25.17. Okay. And the highest paid employee in the tech industry is an engineer who made $49.55. If you want to sort the list in descending order, for example, if I want to sort all the employees within each industry by hourly wage in descending order, because hourly wage is a numeric field, so all I need to do is put a minus sign in front of hourly wage in the order function. So for example, if I want to store the new sorted list in a new data frame called the sorted data 3, and I'm going to put in my data square bracket, order, my data, $industry, to sort the data first by industry. And then within the industry, I'm going to sort the employees by hourly wage in descending order. So I put a negative sign or minus sign in front of hourly wage, my data, $hourly wage. And then outside the parentheses, put a comma and a space. And then let's say I want to run multiple lines of scripts at the same time. For example, after sorting the data, I'm going to view the sorted data 3. Alright, so what I can do is I can highlight both lines of code and then click on run. So now if you look at the result here, we are sorting everything by industry first. So all the automotive workers presented at the top of the list, and then within the same industry, employees are sorted by hourly wage in descending order. So the first employee we see here makes $50 per hour, and the last employee within the automotive industry is the lowest paid employee, and in this case we have 2 employees, both programmers, who made $24.76 per hour. Okay, so this is how you would sort the data in descending order. Now let's see how we can sort a text field in descending order. So in order to sort a text field in descending order, we need to use a different function called the xtfrm. For example, let's say I want to sort the data first by industry in descending order, and then within the industry, I would like to sort the data by hourly wage in ascending order. So I'm going to store the new sorted list into a data frame called the sorted data 4, and I'm going to assign my data bracket order. Alright, so because industry is a text field, in order to sort it in descending order, I need to put in negative xtfrm function, and within the function put in my data $industry. Okay. And after sorting the data by industry, I would like to sort all the employees by hourly wage in ascending order. So outside the xtfrm function, I'm going to put comma my data $hourly wage. And then outside the order function, I'm going to put a comma and a space. Okay. Now let's take a look at this line. So this is going to sort the data by industry first in descending order, and then within each industry, it's going to sort all the employees by hourly wage in ascending order. And then we can view the new sorted list. So view sorted data 4. Okay, let's run these 2 lines together and see what happens. There you go. So if you look at the result, so first it sorts the industry in descending order. So that's why the tech industry is at the top of the list. And then within the tech industry, it's sorting all the employees by hourly wage in ascending order. So that's why the lowest paid employees are at the top of the list here. Right? So what if you want to sort everything in descending order? Well, there is a relatively easy way to do that. All you need to do is to add a parameter called the decreasing equal to true in the order function. So let's see how this can be done. Alright, so I'm going to store the new sorted list into a new data frame called sorted data 5. And I'm going to do my data and square bracket order function. Okay. So first I'm going to sort everything by the industry, my data $industry, and then I'm going to sort everything within the industry by hourly wage. So my data $hourly wage. Alright. And then because I'm sorting everything in descending order, so what I can do is I can put in a parameter called a decreasing parameter, and make it equal to true. Okay. And then outside of the order function, make sure you put a comma, a space. Okay. And then we will view the new sorted list, which is sorted data 5. Okay. Okay, now let's run these 2 lines of code and see what happens. As you can see, it first sorts industry in descending order. The tag appears at the top, and then within each industry, it also sorts the employees by hourly wage in descending order. That's why the highest paid employees are appearing at the top of the list. Right? So that's how you do sorting in R.